So this first section just says divide. A couple things I want to point out, and I can't guarantee you that I pulled one that does this, but you do have to check and make sure you have one for each degree. So if I start with an exponent of 3, I have to have 3, 2, 1, and a constant, all right? If you're missing any of those, you have to put a 0 in as a placeholder, whether you do long division or whether you do synthetic, okay? So an example of that would be like number 6. Number 6 starts at 3, it goes to 2. You don't have p to the first power. You have to put a 0 there. Whether you're doing long or synthetic, you have to have a placeholder if you are missing one of your exponents, starting with the highest, whichever one they give you first, and then going down from there. All right, so when you divide, you may do it 2 different ways. You may do long division. Long division looks like this. We do the regular like we learned in elementary school. We're going to put what's being divided on the inside, and then what we are dividing by on the outside. All right, we're going to say, what do I multiply m by to get m cubed? That should have been a 3. And I'm going to say, well, I would multiply that by m squared. And so then I'm just going to distribute m squared times m, that is m cubed. M squared times 5, that is positive 5m squared. We are subtracting. When you go down, you're subtracting, which is adding the opposite. So I change both of those. And then I just add down m cubed and negative m, 12 and negative 5. Once I'm here, just like long division, I bring down that next one. And then I check it again. What do I have to multiply m by to get 7m squared? Well, that is going to be 7m. And then I'm distributing 7m times m is 7m squared. 7m times 5 is 35m. And once again, because I am subtracting, I always change it to adding the opposite. All right. Positive and negative 7, those cancel out. Positive 33, negative 35, that's negative 2m. And I bring down that negative 11. And then one more time, I'm going to say, what do I multiply m by to get negative 2m? Well, that's just negative 2. And then I multiply negative 2 times m and negative 2 times positive 5. Once again, I am subtracting, which is adding the opposite. And so when I do that, I get negative 2 and positive 2 cancel. Negative 11 and positive 10 give me a negative 1. Negative 1 is technically my remainder, but I'm going to write it like this. I'm going to say m squared plus 7m minus 2 minus 1 over what I was dividing by. And that is my answer with long division. Long division. All right. All right, so you can also choose to do this with synthetic division. Synthetic division looks almost like an upside down division. I'm just going to use my coefficients. So what's in front of the m cubed? That's a 1. What's in front of the m squared? That's a 12. The 33 and the negative 11. On the outside, I'm going to take this m plus 5 and say, what would make this 0? Well, negative 5 would make it 0. It's always the opposite. And so I'm going to use a negative 5 right here. And then this way I add down and I multiply up. All right. So I'm going to add down 1 plus nothing gives me 1. And then I'm going to multiply negative 5 and positive 1. And that's going to go up here. That's negative 5. All right. Then I'm going to add down again. And I'm going to say 12 and negative 5 give me positive 7. And then I'm going to multiply up. Negative 5 times 7 gives me negative 35. Then I'm going to add down. 33 and negative 35 give me a negative 2. And then I'm going to multiply up. Negative 5 and negative 2 give me positive 10. And once again, add down. Negative 11 and positive 10 give me a negative 1. And then I just go back and say, okay, I started at m cubed. So I'm going to fill in starting with m squared. So this is going to be a 1m squared plus a 7m minus 2, and this last will always be my remainder, which once again, I put over what I was dividing by, m plus 5. And you can see that this gives me the same exact answer as my long division did. With synthetic substitution, you are doing synthetic division. It has given you this polynomial, which you are dividing, and it has given you n equals -4. What they're really asking is, what would happen if you plugged a -4 into this polynomial? What answer would you get? But they are specifically saying use synthetic substitution to do this process, meaning I don't want you to plug in a -4 and get the answer. I actually want you to do synthetic division. And synthetic division, if you do it correctly, your remainder will be your answer. Your remainder will equal what would happen if you were to plug this in, okay? And so I am going to do synthetic division just like I did before. Again, if you are missing an exponent, you have to plug a 0 in. So this is not, I'm always going to check it for 3, 2, 1, and a constant. So I have everything I need. If I missed one, I would put a 0 there. And then I'm going to do my coefficients. For this piece, when they give it to you like this, you do not change the sign. You only change the sign when they give it to you in a group, like x plus something, x minus something. If they just hand you what you're doing for synthetic substitution, you use it the way it is. So I am going to use that -4. I am not changing the sign. All right? And then I am going to add down and multiply up. So I'm going to do this process all the way down, just like I would before. All right, this happened to give me a 0. It won't always give you a 0. We're not checking to see if it's a factor. We're actually just doing synthetic substitution. So for this, your answer is not the huge polynomial. Your answer is only the remainder. In fact, if you give me the entire polynomial, you will miss points because that's not the answer. The answer is 0, okay? If you were to take, and you can check it this way, but you can only check it. I need to see the synthetic division. If you were to plug in a -4 and do this whole thing out, just like this, then you would get 0 as your answer. And that's what I'm looking for. So your answer here is 0. It is just the remainder. You can get any number here. You can get, I mean, some of these are positives, some of these are negatives. You can get any number here, but you're looking for the remainder as your answer. The remainder is alone your answer here. All right, page 3 asks for a couple of things here. It says state the possible rational zeros, then factor each. One factor has been given, okay? So the possible zeros, well, that is what each of my factors equals 0 at. It's where I cross the x-axis, all right? And so the possible zeros are based on the last number and the first number, okay? And so I'm going to take these two numbers and I'm going to say, well, my last number is a -5. All my factors of that, well, that's just, it's a prime number. 1 and 5 are the only factors I have there. If that had been 10, that would have been 1 and 2, 5 and 10, all right? So all your factors of that. You're not doing like a factor tree, prime factors. You're doing all of your factors of that particular one. So it's actually positive and -1 or positive and -5. You'll do positive and negative for all of these, right? Because I could say +1 and -5 or -1 and +5. Those both give me -5. And that's how it will always be. If it had been a positive number, I could do positive, positive, negative, negative. So anytime you list these factors, just put a plus and minus in front of it because that's how it's going to be. All right? The other piece of this is the first number. That first number is a 2. 2 is also prime. So my factors of 2 are 1 and 2. And again, it's positive and -1 and positive and -2 technically. All right? So what I do is I take these factors and put them over those factors. So if I start with 1, positive and -1 over 1, well, that's just positive and -1. Then I go to positive and negative 5. Positive and negative 5 over 1. Well, that's just positive or negative 5. All right, I'm going to start back at 1. Positive and negative 1 over 2. Well, that's positive or negative 1/2. And then my 5 over my 2. Positive or negative 5 over 2. Those 4 are my possible zeros. Technically, it's 8 because it's positive or negative, okay? So it's saying if you have a 0 or if you cross the x-axis, it will happen at one of those points. That's the only way it can cross the x-axis, is at one of those points, all right? So that's the answer to the first question. The first question says, give the possible. These are the possible rational zeros. So that's part of your answer. That's the first part of your answer. You list all the factors of the last one, put it over all the factors of the first one, and that is your first answer there. The second part of this question says, factor this particular polynomial, and it gives you a factor. Now remember, if you get a remainder of a 0, then you have a factor. So what we're going to do with the one that they gave us this right here, we are going to divide with that. We're going to divide this polynomial. All right? So I personally am going to do synthetic division here. You technically could do long division if you wanted to, but I'm going to do synthetic. So I'm going to do exactly like I did before. 2, positive 9, negative 6, negative 5. As always, I do have to make sure that it goes 3, 2, 1, and a constant. I'm going to do the synthetic. Because it gave me a group, here I am going to change the sign. It was x plus 5. I'm going to use a negative 5. And then I'm going to do exactly what I've done before. I'm going to add down, multiply up. Here's the thing. When they give you a factor, you should always get 0 as your remainder here on this type of problem, because they told you this is a factor. If it's a factor, it will have a remainder of 0. Think about my example. If you divide 27 by 3, you get a remainder of 0 because 3 is a factor of 27. But if you divide 28 by 3, you do not get a remainder of 0 because 3 is not a factor of 28. The same is true for polynomials. If you get a remainder of 0, then you have a factor. And they told you this is a factor. So this first one, you know you're going to get a remainder of 0 or you did something wrong. All right? So I know that they tell me to list all the factors, factor all of it. So I know that x plus 5 is a factor because they told me, and I double checked and I got a remainder of 0. How does that help me? Well, now I can rewrite this. I had x cubed. I can say 2x squared minus x minus 1. And they want me to factor it completely. This is factorable, all right? So factors of 2 that give me a negative 1. Well, I have a 2x and an x. I need my 2 to be negative. So it's going to look something like that. If you don't remember that, you can multiply across, change it to 4 terms, and factor by grouping. You can factor however you need to factor, all right? You can double check it. 2x and x is 2x squared, 2x and negative 1, negative 2x plus 1x, that gives me negative 1x, positive and negative give me a negative 1. All right? Again, if you don't remember how to factor that, multiply across. 2 times negative 1 is negative 2. Factors of negative 2 that add up to negative 1. That's negative 2 and positive 1. Rewrite it. 2x squared minus 2x plus 1x minus 1. And then factor by grouping. Take out a 2x. When you can't take anything out, take a 1 out. You can see you get 2x plus 1 and x minus 1. So even if you don't remember quickly factoring, you can do where you multiply across if you have a leading coefficient, okay? So these are my other 2 factors. So that answers the second part of this question, 2x plus 1, x minus 1. I have factored it completely. There's actually a way to double check this, all right? What would make this 0? Negative 5, right? If I set that equal to 0. -5 is one of my options, yes? What would make this 0? Subtract 1 and divide by 2. -1/2. -1/2 was one of my options, right? What makes this 0? +1. +1 was one of my options. So you can see that all three of these zeros do fall in the ones that I said are all my possible ones. And so you're answering what's possible, you're doing synthetic division to make it smaller, and then you're factoring the small one, and you're listing the one they gave you and the other ones that you found as all of your factors of this polynomial. This one says to factor completely. So these want you to factor completely. What you're going to do here is you're going to look at these as though it's just an x squared instead of the x to the 4th, right? What would you do if it was just an x squared? If it was just an x squared, you would say, oh, factors of 60 that add up to 16. Well, that's 6 and 10. And normally I would say x plus 6, x plus 10. But this is an x to the 4th. So I'm going to say x squared plus 6, x squared plus 10. And that's actually factored completely, all right? They can be that simple, all right? You do the same process. If I have a leading coefficient, I can do my multiply across. 2 times -5, that's -10. Factors of -10 that add to give me +3. Well, that's going to be a -2 and a +5, right? And then I'm going to rewrite this. I'm going to say 2u to the 4th, using this guy, minus 2u squared, because that's a squared. Then using that one, plus 5u squared, and then leave this alone, minus 5. And then I'm going to factor by grouping. Group the first two. Group the last two. What can I take out of the first? Well, I can take a 2 and a u squared. And I'm going to be left with u squared minus 1. What can I take out of the last one? I can take a 5, right? 5 goes into both of those. And I can say u squared minus 1. Then I have the 2u squared plus 5. That's one of my factors. And I have the u squared minus 1. The thing here is if you have a squared and a subtraction, you need to see if you have a special case, all right? If both of these are perfect squares, u squared is automatically a perfect square because it's squared. 1 is 1 a perfect square? Well, yeah, 1 times 1, right? This is a special case, remember? It's a squared minus b squared. And so the 2u squared plus 5, well, we can't do anything with that. But this one we can break up into u plus 1, u minus 1, all right? Because it's perfect squares. And so this one you can go a little bit further than we did with this one right here. So you are constantly looking for perfect squares. Like, for example, x squared minus 9. That's a perfect square. I could keep going. I could say x plus 3, x minus 3. All right, so you're constantly looking when you have higher exponents, can I keep going with my factoring or am I done? All right, that's the only difference between what we did in the last chapter and these higher exponent ones.